cluster, we have the traditional way where we have a storage system behind it. This is still possible. The storage can be attached via iSCSI, via fiber channel, via direct attached SRS. So here we have the connectivity for the storage. For sure, this connectivity has to be redundant because we build a cluster to have a redundancy for each possible failure of a node, failure of a storage, failure of a cable. And this means that also the storage paths must be fully redundant. In this traditional cluster, Hyper-V, Windows Server does not care about the storage itself. So here, the storage 1 and storage 2 is a third-party solution typically. So it can be a solution that's also based on Windows Server, but traditionally these storage systems were third-party solutions, storage 1 and storage 2. The great thing about this cluster is if one server fails, the remaining server can take the full workload from the first server if we have enough reserve capacity there. Here we see a 2-node cluster. For sure, we can also build 3-node, 4-node, 5-node. We can build clusters with up to 64 nodes with this traditional configuration. 64 nodes traditional Hyper-V cluster is possible. We can start with minimum 2 nodes, but also 3, 5, 7 nodes are possible. When we talk about this clustering, it's important to understand that each node in a cluster has a vote. So each of the nodes we can see here has a vote to ensure that we can build a majority set if anything fails. So if anything fails, a server or a storage or a cable, the cluster checks if the cluster can get the maximum, no, sorry, the majority, sorry for this, the majority of the votes. Now, when we think about these 4 nodes here, if one node would fail, it's easy to get the majority because this node that failed had 1 vote. And so the remaining nodes have 3 votes, and 3 is the majority in a set of 4 votes. But you can imagine it will be difficult if a cluster fails like this. So for example, the cluster does not fail, but maybe we have a separation of the servers. And now when we think about this server on the right-hand side is back again. So now we have the situation, we have 2 votes here and 2 votes here. No majority on none of the both sides. And even if these 2 servers here fail, we have the situation that we have 2 votes on the left-hand side. This is not the majority, this is 50%. And to have a solution for this, Microsoft works with a witness configuration. And the witness can be a file share, this can be a cloud witness, this can be a disk-based witness in a traditional storage. And this witness also has a vote. And now we have the situation, when we come back to this 4-node cluster, then we have the situation, we have this witness, and we have a section 1, and we have a section 2, and we have somewhere a section 3 where this witness is placed. So the witness should not be in section 2 and not in section 1. For sure, all these components can be in one rack, they can be in one room. But when we think in servers, then the witness is another server. We don't need the complete server because the witness only needs a file share. It can be a cloud-based witness, so it can be an Azure storage account. But we need some instance, let's say, that can be used as a witness for this cluster. Now, often I hear, okay, in a 3-node cluster, maybe we don't need a witness, but also in this configurations with 3, 5, 7, 9 nodes, we also should have a witness, because if all the nodes are up and running, the witness has no vote. So actually the witness has no vote. But if one of these nodes here fails, Then we have a new two-node cluster. And in this new two-node cluster, the witness receives a vote, and now we can survive another node failure. So it's important to have a witness. The witness itself is not high available, so you should never place a witness in a sysvol folder, never in a distributed file system architecture. It should never be replicated to another site. The witness is an single point of contact that itself should have a very good availability, but it should not be redundant itself. Okay, I think this witness story is so far clear. Now, in this traditional way, we have an external storage. What's also possible with Microsoft technologies to build a hyperconverged infrastructure. The cluster story is absolutely the same. We build a cluster, we have a witness, but the storage is now not external, but the storage is built based on the internal disk drives in the servers. This means we have an architecture like this here. We have our servers, and we don't have an external storage connected, but we have local drives. Different drive types are possible. And these drive types are redundant across the servers. Not the drives themselves are redundant. The redundancy is built based on an entity. It's called extent or slab, and this extent has a size of 256 megabytes. Each extent has a size of 256 megabytes. And these extents are distributed across the server, and across the servers, we have the redundancy. Technical not correct, but compare it to a RAID across the servers. A redundant array of disks across the servers. It's a redundant array of extents across the servers. This is what the Microsoft HCI technology does, and Microsoft HCI technology means Hyper-V for virtualization, storage spaces direct for software-defined storage, and SDN for software-defined networking. These are the components in the Microsoft HCI part. Additionally, Windows Admin Center for management. We can start very small. In Windows Server 2022, we can start with minimum 2 servers. There's another platform, it's called Azure Stack HCI. There we can start with 1 server, but we are talking about Windows Server 22. We can start with 2 servers. And now it's important with storage spaces direct, we can scale up to 16 servers. I told you the traditional cluster can scale up to 64 nodes. In combination with storage spaces direct, we have maximum 16 nodes. Hyper-V is always the hypervisor. And in the Microsoft HCI stack, we are using industry standard servers. We are using the local drives. This can be a combination of flash drives and hard disk drives. This can also be flash only. And the advantage of using this cache is that the cache increases the performance on the storage layer, because I think all of you know that flash storage is much faster than hard disk storage. But also in the flash storage, we have huge differences compared between traditional SSDs, non-volatile memory express, or persistent memory based on Intel Optane persistent memory technology. So the interesting thing is you can mix these different technologies to find your optimized performance and price point. To give you some numbers regarding the performance, when it's a random access to the storage, we can replace up to 400 hard drives with one SSD. So the SSD has something like 60,000 IOs per second. The hard disk has something like 150 IOs per second. So we can replace these 400 hard disk drives with one SSD, not when we talk about capacity, not when we talk about the throughput, but when it's random access, when we talk about virtualization, we have a lot of random access, then SSD can be up to 400 times faster than a hard disk drives. An NVMe can be up to 10 times faster than a SSD, or up to 4,000 times faster than a hard disk drive. And the Intel Optane memory technology is available in NVMe's, but also in the Optane persistent memory modules. And here you can see the big difference is the memory modules, the Optane memory modules, they are located in a memory slot, so they have a very short distance to the CPU. So we have very low latency. And this is great for low latency applications. And the interesting thing about Intel Optane persistent memory is that it can be used as memory and or it can be used as storage. So both is possible. And if you have heard something about Optane in the future, then it's important to understand that Intel announced that Optane persistent memory will not developed to new versions, but Intel Optane persistent memory and the technology we know today, and this is the fastest storage and the memory with the maximum size available is available today. It's sold today. It's sold also in the next platform, in the next CPU platform from Intel. So Intel Optane is there. It's full supported. You can use it. And especially for this storage spaces direct part, for the Microsoft HCI part, it's interesting. Option 1 in the storage category, option 2 as an high capacity memory when you're running a lot of virtual machines. When we look at the different storage configurations, we can run full NVMe, we can run full SSD, we can combine NVMe's and SSDs, or we can combine NVMe's and hard disks. So these are different possible combinations, and it's always the minimum configuration. For sure, we can also have something like 20 hard disks and 4 NVMe's, or 20 hard disks and 2 NVMe's, or 7 NVMe's only. So this is always the minimum configuration we see here. There's a relationship between the cache drives and the capacity drives. If we have configurations like we see it here we have cache drives, and here we have cache drives. Here also. And what's also important to know, if we decide for a storage layout, we have to use this storage layout in each node of the cluster. So it's always an or between. So we can run full NVMe or full SSD or a combination on NVMe and SSD. It's not possible to build one server with NVMe's only and one server with SSDs only. This is not possible. So we have to decide for one storage layout. Okay, I would say regarding the basics, this is fine. So now we should have a look at the doing, how to build this cluster. And what I prepared for us is an environment where we have an Active Directory domain to have the full cluster functionalities. We always need an Active Directory domain, and my domain controller is this server 1 here. I'm using virtual machines. In a physical deployment, you would have, or in a real life deployment, you would have physical servers. The S2D, CLN01 and 02 are my cluster nodes. And for sure, S2D is the acronym for Storage Spaces Direct, and I will build a Storage Spaces Direct cluster finally. But 90% of what we are doing are the same steps for the traditional cluster, and I will mention this when we start in the cluster creation process. So the first important thing is to get an overview about what is installed in these machines. So these are newly installed Windows Server 2022 machines. They are joined to an Active Directory domain. I mentioned this is important to have the full feature set inside the cluster. And we have the situation that we have installed here data center. Clustering is also in standard. This is important. Clustering also in standard. S2D only in data center. So if we want to build an S2D cluster, we need data center or Azure Stack HCI. This is a different operating system. When we are running a traditional cluster where we, for example, install SQL Server or another workload, then it would be possible to use the standard edition with a traditional storage behind it. So, okay, we have this server system here. We have a domain connectivity here, a domain network, and then I have a network that is named SMB traffic here, or SMB. This is actually not connected. So when we connect this network, let's go to the virtual machines area. In the physical environment, this would be adding the cables. This will be the D02 SMB. Now I will connect this network. And for sure, we need an IP address on this network. And this IP address can be a dynamically configured IP address, or it has to be configured manually. I will configure a manual IP address. So I will use the IP address 102.168.101.1 for this interface here. So I will use this connection for SMB traffic. This SMB network could be also an iSCSI or fiber channel connectivity if you would have a traditional storage system behind it. This would also be possible. In my specific scenario, this network interface will be used for the SMB traffic. Let's also configure this here, the properties and the IP address here, 192.168.101.2. Okay, SMB network. So this is my storage network. So whatever you are using for storage, this is the storage network. It would also be possible in a traditional cluster to use iSCSI or fiber channel. In a storage spaces direct cluster, this is the SMB traffic. So in a cluster, it's very important to think about the networking in detail, because we have to ensure that we have dedicated network connections for each cluster traffic. I will mention a few additional cluster traffics. This can be physical connections, but this can also be logical networks. So it would also be possible to only have two physical interfaces, aggregate these interfaces via switch embedded teaming, and build on the logical layer virtual NIC adapters that are connected to this switch embedded teaming switch, and they provide the bandwidth for the domain traffic, for the SMB traffic. Maybe we have something like live migration. So when it comes here to the settings in this, let's add another network adapter, and this adapter will be used for the live migration traffic. So another one. This should be a dedicated adapter or a dedicated logical interface on the logical layer. I will configure this together with you. So this is the live migration network, and the live migration network for sure also needs an IP address. Let's use the 192.168.101. dot, oh, sorry, not 101.02.1. This is on this host, and the same on the other host. This is the live migration, and the IP address is the 192.168.102.2. Okay. Important is that the interface names are identical. This is live mic, so it should also be live mic here to ensure that the naming is the same. Because when we have the cluster validation wizard only looks on the names and tries to connect with each other. So now, when I ask attendees in workshops, do we need another network? I often receive the answer, yes, we need a heartbeat network. This is not completely true because a heartbeat network is not really required. We will see this in the cluster configuration later. A heartbeat network, we have a heartbeat in the cluster, but the heartbeat is sent via each network interface that is allowed for cluster communication. So we have a heartbeat, but for sure, we have some cluster internal communication. And this is the reason why we should have another connectivity. And this another connectivity should be, let's go to the settings of the machine and add another adapter. And this adapter will be the cluster network. It's for cluster internal communication. For sure, we also have the heartbeat there, but we have the heartbeat also on the domain network. And this is the reason why we don't need a dedicated cluster heartbeat network. So if you have any questions, feel free to send in your question via the chat, and I will take the question and care about it. Let's rename this here to cluster, and also rename this on the other side to cluster, and use the IP address here, the 192.168.103, and the one here for the first host, and on the second host also cluster. And the 192.168.103 and the 2 here. Okay, now we are ready regarding the networking part. So for sure, we could have additional networks if you have some customer-specific traffic, but this is my recommended minimum configuration. For sure, this should be redundant. So 2 interfaces for domain, 2 for SMB, 2 for live migration, 2 for cluster. And for sure, this can also be a set switch embedded teaming, where we have 2 physical interfaces minimum, maximum 8 can be brought in one set switch. And then we combine them with a set switch and provide the logical interfaces to our nodes that use these logical interfaces. Both is possible. In the virtual machine layer I'm working here, it's easier to work with these dedicated interfaces. Now we need some roles and features. And I will install the roles and features here via the tool in the server manager. Unfortunately, my server has a pending restart, so we will need a restart here. We will see this. I will install Hyper-V because this should be an Hyper-V cluster. And now I can see a message, oh, Hyper-V cannot be installed because the processor does not have required virtualization capabilities. This is an easy thing in the virtualization world. So let's shut down these nodes. Then they have the restart. So let's shut down here. And let's shut down the second node also. And what we need is an PowerShell ISE on the host. And let's go to the PowerShell window here. So for sure, this is not required in a physical installation, but you have to enable the virtualization in the firmware or in the BIOS you are using. I have a set -VM processor I need here, and I have the VM name. The name is D201 minus S2D CLN01. There we have an exposed virtualization extension 1. So this is the command we need to enable the virtualization features inside a virtual machine. Let's do this here. Virtual machine has to be turned off. I'll only also doing this on the second node. And now we can start these machines here again, this one and this one. And now we have two things solved. First, the open restart they were waiting for, and the activation of the nested virtualization here. So now I'm using the server manager to use manage, add roles and features. And then next. Now you will see Hyper-V is possible to install here. I will also look into the second machine because we need this machine in a few minutes. And important is to configure each node identical. So each node will need the Hyper-V feature if this is an Hyper-V cluster. Now you can see Hyper-V is possible. In the features, each node needs failover clustering. Also, if it's not an Hyper-V cluster, if you want to build a SQL Server cluster or a file server cluster, then you need the failover clustering. So we have Hyper-V because it will be an Hyper-V cluster what we build. We install the failover clustering and we go to next. We don't change any settings here and check restart destination server automatically if required because the Hyper-V installation needs a restart. The same on the second server. We have a manage, add roles and features. And for sure, if you have 3 servers, 4 servers, 5 servers, you do this on every server. If you want to automate this, I recommend you to use docs.microsoft.com. There we have an PowerShell script provided when you are looking for Hyper-V cluster installation or hyper-converged cluster installation, where the script installs the role on every server you provide. So you can specify a list of servers in the script and deploy this on each server. In our scenario with 2 nodes, I think it's fine to use the wizard-based installation here. So the 2 nodes are installing, the installation is running, the first node is already restarting, the second node is also restarting in a few seconds. If you want to build a traditional cluster, then it's now the time where you connect your iSCSI or fiber channel storage systems. When you are building a storage spaces direct cluster in the Windows Server 2022 or in Azure Stack HCI, then it's the point where you use your local drives you have prepared, you have configured. And I prepared this with the local drives because this is the modern way to build a cluster. But again, both is possible. Both can be used. Both is possible. And the basis, the basic configuration of the cluster is the same for both deployment options. So first, I'm looking into the node 1. But it is not important which node we use for the cluster configuration. Important is to know that after finishing this Hyper-V installation, we will see a new option. It's available in tools, and it's the cluster configuration or the failover cluster manager. So I will close this Hyper-V installation progress here, and let's wait for the server 2. Then we can use tools and failover cluster manager. So we'll also log in here to ensure that this server is ready and prepared. So the failover cluster manager is the traditional tool. There's a new tool, it's the Windows Admin Center. But for a traditional cluster based on Windows Server, I would recommend you to use the Failover Cluster Manager to build this cluster. Later, for management, for sure, we can use the Windows Admin Center. It's perfect. It's recommended to use the Windows Admin Center for management. But for building this cluster, I would recommend you to use the traditional failover cluster manager tools, and I will also use these tools. For an Azure Stack HCI cluster, it's different. An Azure Stack HCI cluster, my recommendation is to use the Windows Admin Center for deployment. And so here we will start. First step is to validate the configuration, because there's no specific cluster hardware from Microsoft or from the Microsoft OEMs. So important is to validate the nodes. I will enter the node names here, D201 minus S2D CLN01. This is the first node. And I will also enter the second node. Okay, both nodes are in the list. Then the next step is important to select run only tests I select. And when I go to next, I can see the available tests. And for a traditional cluster, we need the option storage. This is a traditional cluster with iSCSI or fiber channel. Okay. The storage spaces direct is the option for HCI. And we want to build an hyperconverged infrastructure cluster. So this means we are switching to storage spaces direct and we are removing the storage part. If you are working with a traditional storage with iSCSI or fiber channel, then you return to the initial configuration. So you check the storage checkbox and you remove the storage spaces direct here. So it's important to select the right or the correct storage test. So now I'm going to next. And via next, the test starts. And don't worry if there are red lines in here or yellow lines. This is only the progress. This is information about the progress. The important part is the report of this test here. So important is for us the result of the report in there. And this will take a few seconds till this has finished. So test is currently running. Software update level, now it's